welcome,
Thank you.
and the stage is yours.
Appreciate it. Thank you very much. Good morning, everybody. Glad to be here, and I appreciate the opportunity to speak. Really a little bit intimidated with all the smart people in here on knowledge graphs and graph data science. So I'm really excited to try to share. So first off, stop reinforcing the rift. I like that. I think that's should be our mantra to a degree. Great job. A lot of good information. So I'm going to take it to a different level when I look at knowledge graphs and how we utilize knowledge graphs. Because what I want to talk about is actually the application of knowledge graphs. How do we utilize them in industry? How do we utilize them at NASA? Because all the research that we do, all the technology stacks that are out there, all the information that's there, they're not going to be helpful unless we can actually get them applied in our organizations. We can actually utilize them. And I think yesterday, I think it was the Enterprise Knowledge Group that was doing their talk on how did they actually get their applications out there, how the little workflow for doing that was excellent. If you didn't see that, you got to take a look. A lot of the things that they talked about, I've done over the years. I've been looking at this for over 10 years, but I want to make sure that we look at how NASA's doing it so that you can see how to do it in an organization. I'm of the mindset that we throw things up against the wall and see what sticks. Because until we use these technologies, until we show that it's value, our organizations are not going to use them. Over the last 10 years, I've had a lot of conversations with individuals. A lot of those things that he mentioned in his previous talk were in my mind, but I was too afraid to say in some of our meetings because the ingrained IT mentality is hard to change. And this is technically, even though it's been around for a long time, it's technically a new resource, a new capability within industry, within our organizations, and they're very hard to shift their mindset to something different. So we've got to show them how to use this. There we go. All right. Couldn't be a NASA presentation without showing something from NASA. So, so this is one of our scenes from Hubble, but this is also kind of a representation of how I was looking at knowledge graphs, graph databases, or graph data science 10 years ago when I first started getting into this industry. We've got a lot of information out there. When he was talking about data silos, this is what I was basically trying to signify here. There's a lot of data out there, all over the place. Some of it is cloudy and messy, like on the left-hand side. Some of it's starting to get organized, but it's still very separated. But they're all still connected some way. There's some way we can connect our data sets across the universe to make sure that's all definitely in one segment. So this is me when I first started, looking up at all these data silos, looking and saying, what am I going to do with it? How am I going to utilize it? How do we connect these things, these dots across our organizations? How do we utilize the data that's there? Because nobody's talking to each other. There are turf wars on data. That was mentioned earlier. People don't want to share their data. We need to find a way to make sure that we can share the data and show the value of utilizing our data across the organization. But I also was looking for life out there. I was looking for the people that were actually doing knowledge graphs, using graph databases. I knew there had to be life out there somewhere to do that. So I was trying to find those connections, trying to make sure that we can bring everybody together and start the conversation of how we utilize graph databases, graph data science, and knowledge graphs within our organizations. So I eventually found different groups out there. Oh, there we go. And I'm going to talk about 4 different knowledge graph scenarios that were currently going on at NASA around different groups, different centers doing this. I advise about three of these different groups here on some of the things they're doing, just to see how we can utilize and how we can bring the community together. This particular group is the heliophysics group out of Goddard, and they're actually communicating with various organizations, STEADY, geographical magazines, with SpaceX, and on making sure that we connect. As you know, NASA's starting to commercialize their space program. But we have to share our data with other organizations, with other commercial companies such as SpaceX, or Virgin, Blue Origin. All of those organizations need to share our data. We've got to be able to share it with them appropriately. And this is how we started the communication. So this group out of heliophysics is looking at a mechanism for how they're actually expanding the network. It's not just a knowledge graph to their community, not just one knowledge graph of a particular area or data collection, but how do they join these knowledge graphs together to make a knowledge network? And that knowledge network eventually turns into a knowledge community. So they're really trying to focus on how we can organize all of this information and share it across the space industry, so that everybody has the same type of information, everybody has the same playing field. As what we're trying to do. As we all have the same mission of trying to get back into low Earth orbit, trying to go on into the moon and back to Mars. All of this integration together with the data, utilizing knowledge graphs, knowledge networks, and the knowledge community, allow us to get there safely and make sure that we attain our mission of getting to Mars eventually. So some of the concepts of what they're looking here from a knowledge commons, it's just to look at the definitions again of knowledge graph, knowledge network, and knowledge community. They're using this again just to try to bring everybody together. The knowledge network, they're actually going out and talking to various groups. In this particular case, they do use more of an RDF type of a capability and semantics to get those organizations on the same wavelength and how they're utilizing their data. Heliophysics and planetary science organizations have a strong background in ontologies and taxonomies, and so it was ripe to utilize knowledge graphs in this organization. So they came to me about 2 years ago, says, how do we do this? How do we connect together? How do we try to get people talking? And Ryan McGrath, started coordinating with different groups on how to get together and developing these types of knowledge networks and getting people together, getting organizations together, eventually developing a knowledge community. But here's, if you want to reach out, if you want to talk to some of these folks and get an understanding of what they're doing, the slides should be shared, I'm assuming, and the slides there will have links to different folks within NASA as well as outside of NASA that you can talk to about the NASA Center for Heliophysics, Barbara Thompson, on her communities of practice, how to establish a community of practice for knowledge graphs. Get those into your organization, because the more we evangelize what we're doing, the more we try to put these things in industry and put this in our organizations, the better we'll be able to get people to understand the value of knowledge graphs, but the better it is to take that research and those technologies and start infusing it into our organizations. That has been one of my toughest challenges so far, is getting the mindset shifted from strictly SQL or RDBMS systems and start moving over to more of graph technologies or a combination of the two so that we can utilize it. And IT technology, they're kind of set in their way, and you really got to show them the value in order for them to shift it to a different degree. Also, the National Science Foundation Convergence Hubs. If you haven't seen that, go to them. There's a lot of work. Some of their accelerator grants are out there. You can look at that work around knowledge graphs, utilizing knowledge networks. There's a ton of money out there from the NSF that people are able to apply for some type of knowledge hub. And then the Heliophysics, those have the knowledge network, Helio Now, where they're starting to capture all of these things on GitHub. And it's open to anybody that wants to come in, take a look at what they're doing, contribute, and really start sharing the knowledge of how we're trying to combine all of these things together. The next one I want to talk about is one that's kind of a little closer to my area, because it's coming from where I used to work at Johnson Space Center. It's the Human Research Program. They have what's called an evidence book. Now, this evidence book basically looks at, from a medical perspective, they're looking at different types of experiments on astronauts and some of the different results from that. You can see their mission here is to enable space exploration beyond low Earth orbit by reducing the risk to human health and performance thought. That's a pretty good mission. But they're putting everything, when they say evidence book, they exactly mean that. It's a book. So they've got all that information in these piles of papers, and in order to read through it, they've got to look through it and see what the commonalities, see what the issues are, try to go through the experiments. So they're looking at developing a knowledge network that would allow them to grab all of this information. So this is a basic example of some of their information in an evidence book. The items in bold are basically your labels that are going to be going into your property graph. So you have a sample, and those samples could be a blood or saliva. Shuttle is going to be what they're going to be experimenting on, or the crew members are what they're going to be experimenting on. The assays, and highlighted there in yellow, or the different graph model. All of that stuff can now be put into a graph model. So they're looking at ways of how to extract that from the evidence book into the graph model to develop a kind of a graph model that looks something like this. There. So this is their very small, graph model they're trying to look at, where they basically have their samples down there, the saliva and blood, the essays that go to that eventually go to a publication and able to present this information and be able to use this information. But the other part, and not just the publication, is be able to look up this information quicker and faster on some type of search mechanism or capability for them to combine the different evidence samples within the evidence book to understand what's going on, and maybe there's differences or commonalities across some of the experiments. And these are the tools right now they're using. This experiment, like I told you before, we're just kind of throwing things up against the wall to see what we can do. So there's a lot of different ways to try to extract this information. So they're looking at a lot of different types of NLP pipelines to be able to look through their evidence book, to be able to pull those out from top to back, just entity extraction, various different things they're looking at trying to use. So it's more of an experiment on an experiment to try to understand how they're able to go out there and develop this knowledge graph that, again, will basically be able to be utilized across NASA very quickly, and then combined with some of our other medical research that we currently do. We currently do about, I think over our last call, we've had over 2,000 experiments conducted on the International Space Station by our astronauts. All of that information is going to get stored back into a knowledge graph to be able to combine with the evidence book. Next one I want to talk about, and this is more within, again, the industry. This is a sample. I don't know if anybody's ever seen anything like this. Has anybody, or just me? I've sat in too many meetings looking at this. This is a risk board. This is basically laying out all the risk of an organization or a particular area. What's the likelihood and consequence? And the likelihood and consequence is usually like this. Yeah, I think that's about right. And they put it up there and they put these information on there, and you're supposed to understand that this risk is tied to risk A, is tied to risk B, which is tied to risk F. And you know that if this one happens, this one's going to happen maybe more frequently. So it's really hard to understand this, and you really have to try to keep track of what's going on. So the concept here that was brought to me, and we're taking a look at this, is to turn this into more of a graph, a knowledge graph that looks something like this. So a risk knowledge graph will start off with a hazard. And there's three different areas. There's a hazard to the individual, to the team, and to the system. So that hazard could impact an individual, looking at and that could be a health and performance risk that's there. And that health and performance risk could hurt the individual readiness of that crew member. Well, the system down there, the human system integration architecture, also has an impact on the individual and also on the crew capability. And the team section over there, the individual readiness can impact the team functionality. And as you see, it just starts adding and adding and adding as you add more and more risks. So they're looking at ways of trying to combine these things to develop something like this from a one particular non-ionization radiation risk. And I'll just let you look at the chart there, but basically it's looking at various areas. You have, in the top part, you have radiation and you have distance from Earth. Two different risks upon this. You have radiation itself from sunlight or laser that can cause eye injury or skin injury, which could eventually lead to loss of mission if we're not careful. But the other impact could be the distance from Earth. You know, where you are, how far away you are from the Earth, the less protection you have from radiation. That could also impact some of the risk and add to this. We're hoping that by combining these with different types of risk along a knowledge graph, we'll be able to show how some risk can impact other risk and follow that knowledge graph and easily pull it out to understand that if risk A happens, you're going to have to think that risk F or L or P down the road could also have a greater impact. Somewhat in the concept of a Bayesian network, you're looking at this as far as a knowledge graph to try to understand the different connections between the various risks. So these are some of the things that we're currently working on at NASA to try to make sure we can utilize. I bring this up because we've got a lot of good talk, a lot of good discussion about, you know, the technology and the research, and I love it. It's great to see all of that work going on, but we've got to take it to the next level to how do we take this and apply it. And we've got to use that research and apply it in some of these techniques. Will this work? I'm confident, but we'll see. You know, that's all about experimenting, and we have still experiment within our organization to try to do some of these things. And that's really what we're trying to do as we move forward. The last thing I want to talk about is a project that I'm currently working on in the human capital realm, in the people analytics area. And in this case, we're taking information about, on the left-hand side, occupations. In occupations, we started with a taxonomy from ONET, which is the Department of Labor's occupation database. And within that, you have about 2,000 different occupations. Those occupations have various elements that are associated to those occupations. It could be abilities, tasks, knowledge, skills, certification need, licensure, job localities, readiness, uh, different information around that job. It's all within that database already, and I can import that into a graph database. So based on the information of that occupation, and in this case, I'm just looking at the knowledge, skills, abilities, tasks, and technologies, what it takes to do that work. I was able to use that textual information to create a dictionary, to basically use that in a Dr. model, which then I can take the employee information, and the employee information could be their resume, their CV, their LinkedIn profile, publications they've done, work they've done in projects. Try to find similar items in that can say this skill or this piece of knowledge is similar to the work that you've done over here, or similar to this type of capability you've taken care of, and try to build those relationships. We're getting close to be able to merge the two together, and putting that all into a graph database, and being able to use various algorithms to pull things out such as skills path. You know, what skills, what are your normal progression for different skills as you're going up in your career? We can add training information, because in training information, you also have knowledge, skills, tasks, and abilities in those types of things, to understand if you want to learn something or you want to get to your next level, or I want to upskill an employee, these are the things they need to do in order to make sure that they are capable to do this particular position or job that we're looking for them to do. All of that will then provide us answers such as what skills are we losing? Do we have the right skills and competencies to get to Mars? What do we need? You know, what are we missing? What are we looking for in the future? And how are we going to upskill our employees to make sure we can get there? So this is a project still in work, and sorry, I'll go back. This project is still in work. We're trying to move a little forward, trying to add some additional algorithms to try to make sure we can extract the information. Our next thing that we're looking at for this particular project is how we we're looking at specific NASA competencies that only NASA technically does. Because before commercialization of space system, there weren't a whole lot of people that went to the moon or out into space or got up there. So we've got some specific competencies we're looking for. So now can I develop some kind of tagger, annotation tagger or something to take those competencies and find those within individuals? So we're looking at trying to train that against research publications to say, this competency is similar to this information within this research publication. Now I have a list of various types of ways to define that competency so that I might be able to apply to an individual or apply to a job, or try to figure out if I want to create a job profile, I need these competencies, put them together, which are tied to these people, into this training, into this project. I can then bring them all together and say, this is the group I need to do to get this job done. So those are kind of the things we're thinking of. We're throwing a lot of stuff up against the wall, like I said, primarily to use this technology to get it out there to show value. As the Enterprise Knowledge Group said yesterday, I mean, that's the easiest way to get organizations to start working with knowledge graphs, is you find these types of value, these types of projects that provide value to the organization, work on them, showcase them. They start saying, okay, this is great. Let's see what else we can do. Normally, I will, in my organization, I will publicize these things internally. And I'll guarantee you, once I do a little publication, a little blog, a little item, I'll have 10 phone calls within the first 5 minutes. That thing gets listed out there on our website, internal website, because people go, how did you do that? Can you show us? And that's kind of how you build value and start working through that. And we learn from that. There are mistakes I made over the years in some of these things. I have to go back and start over. But that's the beauty of this, is you can continue going and build that value and do that. And we're at a precipice here where I think knowledge graphs, graph data science can move forward quickly, but we have to show the value within the organizations. Without that, I mean, the research is there. The research is great. Now we got to apply that research. That's what I'm here to do. That's what I'm trying to do. And I hope that you guys take an interest in trying to apply some of these things. And here, if I stick the landing here, I I open it up to questions. You feel free to reach out to me. If you don't know, these are the dragons from SpaceX that come back down and land. I use this again in most of these things just to show a lot of the work that we do at NASA, not only internally but with commercialization. But feel free to reach out if you have any questions. Love to connect, and I'll open up to the floor.
Thank you, David. And thank you for leaving plenty of time for questions. This is great. And actually, so there's so much time that I will start. I hold the mic after all.
Okay.
You showed us two projects, and you discussed a lot about graphs, but less about knowledge. And my question is, for example, you showed two projects where there were individuals, the risk project and the skills project. You have the notion of employees on one side, individuals on the other. Is there an effort to have an ontology, a model across these different projects that you're doing?
Definitely, there are work on our way. Well, I'll back up a little bit. There is a knowledge management organization across NASA. Each of the centers has their own knowledge management office. Up until 2 years ago, was part of the knowledge management office at JSC, leading some of the technology aspects of how do we organize our taxonomies and ontologies across the centers? How do we combine that across the agencies? So there's definitely an effort to develop those things first center-wide, and then how do we connect those across the centers for an agency-wide thing? And then how do we do that across different functional areas, different programs, whether it's planetary science, heliophysics, propulsion research, or things like that. So it's definitely an effort going on, but it's one of those things where people don't understand it. And until we can, again, show the value of why this is important, it's slowly moving forward, but we're getting there.
Thank you. Questions?
Hi, big fan of your organization's work.
Thank you.
So I happen to be listening to a podcast that happens on from the BBC, you can tell by my accent, last night on Apollo 13. And so it was interesting to see you show that graph with the chain of events where, in the podcast, if you're not aware, from what they described, that disaster started with a drop of 2 inches. So it reminded me, I was reflecting as I was walking around the park here, some of the work we do with onboard medical devices and patient diagnostics, where you need to operate that in the worst case scenario where you're in a disconnected setting. Thinking about the journey you're on and the journey to Mars that's coming up, have you considered taking some of the work you're doing, presumably in data centers, and putting that on board?
Yes, the simple answer is yes. The more elaborate answer, or longer answer, there's been work has been done at JSC for trying to figure out how do we get enough information into some kind of storage device that gets to take it to Mars with the astronauts. Because as you get to Mars, there's a 40-minute lag between communication between the astronauts and mission control. 20 minutes from Mars to Earth, and then 20 minutes back. So there's times that they're going to have information at the ready, without having to wait for 40 minutes. So one example I can give you is they've been working on what they call doc in a box. It's taking basically a lot of information about medical procedures and medical information within some type of graph model, within some kind of computational capabilities that allow them to ask a question within that and then find the best answer. This is, give the symptoms the astronaut may be having, or give the condition that's going on, and based on that, here are some possibilities to do, or what you need to do, or here are the steps you need to do in order to rectify the current situation. So yes, and a lot of the concern was more from a technology aspect of how do we get all that information into a storage capability, and can we get that storage device small enough and light enough to get on the rocket to get it over there.
So we have a question online. Are the cages created by NASA going to be made available to the public?
Some will. The first two that I showed will be open sourced eventually. As far as the knowledge network and the knowledge commons group, there is a GitHub site. The evidence book will be looked at to be open source. The risks, no, because that's a little bit proprietary information in there. The people, the one I'm working on, I have open sourced some of that. I can't open source the skills portion or some of the proprietary information in it, but the how I develop the knowledge graph itself is on a GitHub repository.
Any question in the room?
Go ahead.
Yeah, a question was that you showed on the risk side the Bayesian networks there. What's the advantage of using the graph, knowledge graph over the Bayesian for that situation for risk analysis? I mean, BBNs are naturally designed for risk analysis.
I agree. I mean, there's definitely a. I think part of it has come down to monetary aspects, capabilities, and knowledge of the folks trying to do the work in order to get that Bayesian network in there. Some of the from a application standpoint, some of the tools out there are fairly expensive. In some of our organizations, I mean, yeah, NASA gets a good sized budget, but each organization has to manage their own budget. They're trying to figure out, how can I do this? Do I need to pay X amount over here, or can I do it in house? A lot of that. The thought here is can they connect those risks across easier, so that you can see again if one risk over here happens, will there be an issue here? And that was the question I was trying to ask in the data science thing yesterday was, is there a way to get a probabilistic graph for the Bayesian network somehow inside of a graph? And talking to someone, it's like, it's probably doable, but very hard and clunky to do. So why do it? Why go to that trouble of doing it? So it's a good question. Yeah, and I don't know. I mean, I think a lot of it has to do with the connections between the risks down the road, and how do we visualize that in the graph? And if we can combine the two together somehow, I think we've got a better potential there. Okay.
So a voted question online. What kind of professional backgrounds do members of your team, your KG team, have, and how are you building those skills within NASA?
So excellent question, because I think I asked the same question yesterday to one of the speakers about how do you find these skill sets in individuals, because it's difficult. Knowledge graphs, graph data science, even though they've been around a long time, they haven't been in the mainstream. If you look at the different lists that some of the data science skills that you're looking for, of course, Python is going to be up there pretty high. SQL is up there pretty high. You don't see generally graph data science or graph algorithms or graph theory in most cases. It depends on the industry. So it's really up to me to try to find individuals that have good programming skills and understand graph theory, and then try to develop them into how to utilize graph theory within an organization to apply those things through the various models and the various capabilities that are out there. It's difficult right now because it's hard to find people. But I will say this, everybody that I have trained on knowledge graphs and utilizing has thanked me. It has basically opened the world, saying, I hadn't seen this before. They don't teach this in school. They don't. I mean, if it is, it's maybe a 1 hour lesson on, here's something that's coming up, and that's about it. And they've all, gone back and utilized. I take an intern just about every semester, and those interns will learn some of this, and many will go back and try to, advocate for getting this, but they've taken it to their other organizations. So it's expanding from that. I don't know if I answered the questions, but the strategies right now for me is, I guess, it's just to try to teach them myself, or try to point them in the right direction and where to look for information and learn, and provide them a lot of research documentation. Yeah.
Thank you very much, David.
Thank you. I
Thank
appreciate
you.
it.
Thank you for
coming. Thank you, everybody.